Oh, I was so close. All right. So to continue on, write your answer to question 6 with proper sig figs. So I can only have 3, which means I'll flip it back over again. I have to round to this position. I need 1, 2, 3. So I need to round this. So double check over here and say, what's that going to do? Well, that's going to round that down to 200, which is what I was going for before I got cut off. All right. But if I write it like that, then that's only 1 sig fig. So I need those zeros to count. So how can I make them count? Well, if I just put a decimal there, then that does it. That says I went to this position over here to check my sig figs, and this is how accurate I'm being. It is exactly 200. So that's one way to do it. Another way is to write it in scientific notation. So we could go 2.00. Now those zeros count, and then we can go times 10 squared. And this was meters, by the way, 200 meter sprint. All right, lastly, we're going to do some dimensional analysis here. Oh, look, it's bleeding through the paper, my ink. All right, a couple things that I wanted to give you first. That this symbol here, the lowercase a with a c, sub c, represents this thing called centripetal acceleration of a circling object. A v represents the speed of that circling object, and the units of speed are meters per second. And then lowercase r represents the radius of that circle, and that has units of meters. So we're going to use dimensional analysis and this equation, which says AC equals v squared over r, to check for the units of centripetal acceleration. So what do we think those units are? There's a couple ways to do this. I don't want to belabor the point here, so we'll try and go through it fairly quickly. All right, just to rewrite that equation, it's AC equals v squared over r. So the first method is to just look at the dimensions. What are we measuring? What does v have in it, and what is r? All right, so the first one, what we'll do is let's just go right to the speed. All right, speed, meters per second. Well, that's a length divided by a time. So what we're going to do is replace that v with L over t, because that's what it is. And then don't forget that squared. That's going to come over here. We're squaring the whole thing. And then we're dividing by the radius, and the radius is in meters. And so you know what? That's another length measurement. All right, so let's just continue on. What happens when we square that? Well, we get L squared over t squared. And then that whole thing is over L. So as you can see, this L is going to cancel out with one of these two up here, and we end up with the squared disappear. The lights shut off on me. All right, so we still have one L remaining, and then we have a t squared, and that's it. So it's going to be L over t squared. So that's the proper way to do dimensional analysis, and then we can go from there. We can take it a step further and say, well, what are the units? Length is in meters, and then time is in seconds squared. And so we do end up with meters per second squared, which is the units for acceleration, and that's what we are trying to show, because it says to check for the units. All right, so that's one method. Another method is just to plug in units straight up. And so we can do that. We'll take the meters per second for the speed and the meters for the radius, and that will look something like this. We're going to go meters per second and square that whole thing. It's almost identical, but we're just using different symbols instead, and meters for the radius. So it's going to be meters squared per second squared all over meters. That meters is going to cancel out with one of those. And so we are left with meters per second squared. That actually seemed a little bit easier, just to plug in the units. But and that is it. All right. So if you are, don't feel bad about this. If you don't feel like you 100% understood all of these things, it's not that big of a deal. These are pretty insignificant in the grand scheme of things in terms of physics. We haven't even really done any physics yet. We've been in school for 3-4 weeks, whatever it is. And this is all just kind of intro stuff. Some of the tools that you might use throughout the year, but you don't really have to. You're not going to be required to do most of this stuff. I would say the only thing that I am going to require is this LISA method, where you're showing your work with a list and so on and so forth. Being able to do the rest of this stuff is just helpful, but it's not really that big of a deal. So I hope this helps. and I will see you soon. Okay. And so